Hey there, guys. This is lesson 3, day 3 of week 4 of your digital week. So we're going to start here with lesson 21. Problem number 21, and just run through really quick some skills that you might need for some of these. 21 just says that the data in the table below shows the number of people at the pool 1 hour, 2 hour, 3 hours, and 4 hours after it opened. Which graph below shows this data? So if you remember me telling you before that if you have a graph, this down here is your x-axis and this coming up here is your y-axis, and you always plot points by the x and the y. So we're looking for hours and number of people, and which one is going to be your x-axis and which one is going to be your y-axis. So if you look here, hours is down here on the x-axis and number of people is up here along the y-axis. So that means that these are your x-coordinates and these are your y-coordinates. So your first coordinate is going to be graphed as x1, y 1. So you have your x, y, so your coordinates will look like 1, 1. Okay? That means your second coordinate, your x will be 2, your y will be 3. So it'll look like 2, 3. So you'll go over 1, up 1, then over 2, up 3, and then so on and so forth until you find the graph that has all 4 of those coordinates correct. Okay? Let's move on to our next question. Number 22 has us here with a mixed number minus a mixed number. This is just where we recently cut off in school. So 3 2/5 minus 1 1/10. Okay, you have to first come over here and find your common denominator between 5 and 10, which is 10. Ask yourself, how did I get from 10 to 10? Well, I multiplied by 1. So whatever you do to the denominator, you have to do to the numerator. 1 times 1 is 1. Same thing up here at the top. How did I get from 5 to 10? I multiplied by 2, and 2 times 2 is 4. Don't forget to bring those two whole numbers over. Now you have a subtraction problem you can do because of the common denominators. Okay? Now, if we come a little bit further down, you have 23 and 26. If we want to round to get an estimate, you have a bunch of whole numbers here. So if we round all these to the nearest whole number, 1 and 32/100, we look here, we're rounding to the nearest whole number. 1, you look to the right, you see a 3, means we're going to round down. So we have 1. Here's the nearest, or here's the whole number. 0, look to the right, we see a 9, which means we're going to round up. So another 1. Here's the 2, we're going to look to the right, we see a whole number of 2, and then we see that 9 looking to the right, which means we're going to round up. So we have a 3, so 1 plus 1 plus 3 equals what? That's what you're rounding to. Number 26. This is a concept that we are not familiar with, multiplication of fractions. So you're going to have to rewrite this with your 18 over top of a 1. That's the same thing as 18, but it's just how you see it in fraction form. So those are equivalent fractions, or equivalent numbers, okay? Now, what is important here is that you learn a concept of kind of canceling out. Nothing can be done with the 5 and the 1 because that 1 is as simple as it's going to get. So the 18 and the 6, however, both have a common number that they can both be divided by. They can both be divided by 6. So we can simplify this down a little bit. We'll keep the 5 because we know that that couldn't be simplified any further. But 6 divided by 6 is 1. And we're going to keep that other 1 over here because we couldn't take that down any further. But 18 divided by 6 is 3. Now, in order to multiply, you multiply across the two numerators, then across the two denominators, and you get your answer. And then you reduce any way you see possible. Okay? Now, looking at 24 and 27. 24, again, multiplication, but now we have another step that we have to complete, which is, turning our mixed numbers into improper fractions before we multiply. It's very easy to do. You take your denominator, you multiply it by the whole number. You're going in a clockwise motion. Take your denominator, multiply it by your whole number, add the numerator. That becomes your new numerator. So 3 times 2 is 6. You go this way. 3 times 2 is 6. Then you go this way. Plus 1 is 7. That's your new numerator. Okay? Your denominator stays the same. Multiplied by 7 times 1 is 7. Plus 1 is 8. And again, your denominator stays the same. All right, but now we can bring in that concept of going across and kind of bringing things down a little bit so they're easier to deal with for us. So that way we don't have to reduce our answer. 8 and 2 do have something in common that they can both be divided by. That would be 2. All right, so we'll bring that over here. 2 divided by 2 is just 1. And 8 divided by 2 is 4. And then we have your 2 7s right here. 7 and 7 can both be divided by 7. And when you divide 7 by 7, you get 1. Now you just multiply straight across. Like I said, the two numerators by each other, the two denominators by each other, you get an answer. And if you have to simplify, you simplify. All right, number 27. You have something here that might not look completely familiar, and that is these brackets. Now, just remember, it says to evaluate the expression, we are going to use order of operations. We're going to use PEMDAS. Now, brackets still act as parentheses. They're just like bigger parentheses. So you need to look at them as more important parentheses than regular parentheses. And we will solve what is inside those before we do anything on the outside. So we're going to follow PEMDAS within the brackets first, okay? Which means we'll do these two parentheses first. 3 times 5, 15, and 5 divided by 1 is 5. So then you keep those. Those are still inside the brackets, 100 divided by on the outside. Keep treating the brackets like parentheses because that's what they are, okay? And then you can solve for the brackets. 15 plus 5, 20, and then you can bring the last piece down and solve for the rest. Okay? Now, 25 and 28. Number 25 just asks you what is the volume of the length of 1 cube. What is the volume of this whole thing if the length of 1 cube is 1 foot? So remember that volume equals length times width times height. All right, so the length here is 5 feet. The width is 2 feet. And 1, 2, 3, 4, the height is 4 feet. Okay, so you have 5 times 2 times 4 as your equation that you have to solve for this. Number 28 says each unit is 1 mile. How far is the school from the library? So if I'm doing that each unit is 1 mile, that means that I'm going to do school from home for you, and then you can solve school from library. That means that to get from school to home, I walk 1, 2, 3, 4 miles. Each one of those little boxes is equivalent to a mile. So how far is it from the school to the library? That's what you're asking yourself. All right, now moving down, we're looking at 29 and 30 over here on the left. So 29, you are solving 2,077 divided by 56. Now, it's a big guess and check problem, so make sure you're paying attention to what you need to do. When you have multiple choice and you're getting stuck on maybe what the first thing is, this multiple choice is giving you a very big hint on what the first number is going to be. So, test-taking strategies here, play to your strengths, and use that as your first original guide, okay? And finally, number 30, it says Kate received $20 for her birthday. She used $8.15 of her birthday money to buy flowers for her mom. How much did she have? Excuse me. How much money did she have left? So you're going to use the 20, and I would put the dollars and cents because you have to subtract $8.15. So you're going to need those zeros to help you line up the place values and the decimals here. Because remember, when you subtract decimals, you have to bring the decimal straight down when you are all finished. Okay? You guys know where to find me if you have any questions. I'm here for you if you need anything, and I'll see you here shortly for our Google Hangout.